In this presentation, you'll see how a continuous build automation system can be assembled using the Meister build engine combined with CollabNet Subversion for SCM operations. To start with, let's define continuous build automation. It consists of standard continuous integration, whereby source code is repeatedly built based on changes to the source repository, plus ALM workflow, and includes dependency analysis, build script generation, and auditing capabilities. Together, these give you a build system that goes beyond simple continuous integration, beyond basic ALM workflow, and allows you to act on dependency information, generate build scripts based on changes in the source repository, and provide sophisticated auditing to make sure that both internal and regulatory audits are passed. There are two approaches that you can take to doing continuous integration and more broadly to doing continuous build automation. You can drive continuous integration from the CI tool, or you can drive it from the SCM system. In this demonstration, we'll see both approaches. To begin with, we'll start with the Subversion repository. We have a single repository where developers have their own working copies, and the Meister build tool has its working copy that effectively is update only. So a developer will use Subversion on their desktop. They'll check into the SVN repository from their local working copy. At build time, Meister will also use Subversion through its integrations, and it will read code from its working copy of the branch that is being built and go ahead and do the build. Now let's take a look at the details of how the system works in practice. Let's look at our first approach, where the continuous build automation is being driven by the CI tool, in this case by Meister. We start with a workflow that will run on the local computer. It updates a Subversion workspace. It generates a Meister build control file, which you can think of as a make file for the Meister system, and it goes ahead and it executes an incremental build and generates some reports. If we want to drive this build continuously from Meister, we'll go to the Continuous Integration tab, and we'll tell Meister that it's going to update an existing Subversion workspace. We'll tell it where it's going to look to actually monitor and check out code changes, and in this case, we'll tell it to run every minute. Once we save this change, we'll let a minute elapse, and Meister will go ahead and do the build. A minute has elapsed, and Meister kicked off the build as we expected. Since we didn't make any code changes, Meister didn't have to do any work. It looked at the build, determined that there were no file changes, and exited. Now let's make a code change and see how Meister behaves in that case. So we're in Visual Studio, and we'll make a simple code change, and we'll save it. And then just to show you what's going on, we'll go out into DOS, into the directory that's housing this particular solution. And I have the Subversion commit command ready here. So we'll execute that command, and we'll send it over to Subversion. Meister is monitoring the repository overall. And what it's going to do when the clock ticks, it's going to see if there are any updates to be had. If there are, it will go ahead and build those updates. So let's take a look. So we see that this time Meister is actually building the file that changed, linking that file, and then finishing the job. So that gives us a good sense of how you can start with the continuous integration server in Meister and integrate back into Subversion. Let's now take a look at how you can trigger the continuous build from Subversion, and then we'll finish up by taking a look at some of the reports that Meister generates to help you control and manage your build process. So the first thing we'll do is to disable the build trigger in Meister. So we've disabled that. At the same time, we want to go into Subversion and enable a hook. And this is a very simple hook. We'll just type it to the screen. And you can see that the hook does one thing. Every time a code change is made in this repository, it calls the Windows build with SVN workflow in Meister. So we'll make a code change, and we'll save it. And we'll go into Subversion, and we'll commit this change to the repository. And what we should see in Meister, which I've put behind our DOS window here, is that as soon as this code change is committed, the build will commence. And sure enough, we'll switch over to Meister. Again, it's doing an incremental build, so you see that we've changed genepool.cpp, therefore its object file is being compiled, and a link is occurring. Finally, let's take a look at some of the reports that you can generate from a Meister build. I'm going to pull up one of the reports that we generated from one of the recent builds that we did. This build audit report is for the GA driver program that we built. It has information about the operating system, including the patch level, information about the environment, and finally, information about code that came from Subversion, including its version number, date and timestamp information, along with information about programs and files that were dependencies that came from the file system itself. This report is generated automatically just by running a build. So whether we were doing a full build, for example, a production build, or a continuous integration build that happens on every check-in or every half hour, we would generate a report that told us exactly what changed, what its version number was in Subversion, and equally as important, the names and locations of any files that were used in the build that are not under version control. To summarize, continuous build automation with Meister and Subversion gives you a robust version control solution combined with a robust build automation and auditing solution so that your continuous builds are giving you actionable, useful information to help drive your successful development efforts.